Okay, hi. We are going to be working with the binomial theorem to find and express something like a plus b to the first power, right? You know that in this case we can just multiply a plus b times a plus b times a plus b times a plus b, and then FOIL the first two. Maybe we can FOIL the second two and just multiply everything, right? To the first power should not be so much problem or a lot of work. But what happens when the 4 is a bigger number, let's say 6 or 7? That then becomes a lot of work, and plus there's a lot of places where we can make mistakes, right? So we can use the binomial theorem. I'm going to show you two ways of using the binomial theorem. The first one is using combinations. So we are going to use this formula right here. That sign, expression sign, means that we are going to use factorial. Factorial means that I'm multiplying the number times every number before that number. So for example, if we have 4 factorial, that means that I'm multiplying 4 times 3 times 2 times 1. So that's 24, right? So just like that with any number. Okay. So in this case, when we have this expression, we can just use the factorial to start reducing the number. Okay, so for example, in this case, I'm going to have 4 choose 0. That's the first one. Then my second one is going to be 4 choose 1, and so on. I'm going to be ascending on the k value, right? So 4 choose 3, and the last one is 4 choose 4, right? Now, the variables, the first variable, the a, I'm going to start in as with the exponent, with the same exponent as on the binomial, right? To where I'm elevating the binomial. And then I'm going to go in descending order. So this one is a cubed, a squared, a, and a to the 0. Now with the b, I'm going to start from right to left the same way. B to the 4th, b to the 3rd, b squared, b to the 1st, and b to the 0. In this case, because this is positive, all of them are going to be positive. I'm going to show you later what's going to happen when we have a subtraction there, right? So now I'm going to go one by one and express this and simplify that equation. So I have 4 choose 0. So that means that I'm going to have 4 factorial divided by 0 factorial. By the way, 0 factorial is the same as 1. Okay, so 4 minus 0 factorial, right? So I have 4 factorial divided by 1 times 4 factorial, right? Because 4 minus 0 is 0, and as you can see, this one, it should be 1. So that means that this expression is going to be 1. Okay, by the way, when you add both exponents of both variables, as you can see, all of them and every term, when you add them, they're going to add to 4. So 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4. So this one is going to be a to the 4th, right? Because b to the 0 is 1. I'm going to do the same with 4 choose 1. So this is 4 factorial divided by 1 factorial times 4 minus 1 factorial. So this is the same as 4 times 3 factorial. I'm going to explain why I'm just leaving it at 3 factorial. Divided by 1 factorial is just 1 also. So I have divided by 3 factorial. Okay? So that means that I can cancel out the 3 factorial with the other one. So this is the same as 4. Right? So I have plus 4a cubed times b. Plus, I'm going to do the same with 4 choose 2. So this is the same as 4 factorial divided by 2 factorial times 4 minus 2 factorial. Okay, so this is 4 times 3 times 2 factorial divided by 2 factorial. Let me times 2 factorial. right? So I can cancel out one of these ones. 2 factorial is the same as 2 times 1, so it's 2. So I have 4, 3 divided by 2, so this is 6. Okay, so that means that this 6 is going right here. So 6 a squared b squared plus, let me get a little bit more space right here. Right, so let me move this up right there. So 4 over 3 factorial is the same as 4 factorial divided by 3 factorial times 4 minus 3 factorial. So this is the same as 4 times 3 factorial divided by 3 factorial times 1 factorial. So we can cancel out, and we know that this is the same as 4. So I have 4 a times b squared plus, if we check the 4 factorial, so, right, so I have 4 factorial divided by 4 factorial times 4 minus 4, that becomes 0. So this is the same as 1. So I have 1, a to the 0 is 1, so this is just a, right? So my solution here, I'm going to write it in purple so you can see it better, is equals to a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a b squared plus b to the 4th. So this is my solution, right? So if we take a to the b, a plus b to the 4th, and then we multiply all those terms, a plus b times a plus b times a plus b times a plus b, and we FOIL, at the end we're going to have a to the 4th plus 4a cubed plus b times b plus 6a squared b squared plus 4ab cubed plus b to the 4th. So now that we have seen using the combinations, I'm going to show you another method, and this one is using the Pascal triangle. Pascal triangle. Right? So the Pascal triangle begins with a 1, right? The second lines are going to be all 1s, right? Okay. My next sign is going to be 1, 1, and then I'm going to add those 2 to find the solution, right? Another way of seeing it, this is that from this top number, I have just one way of getting to this first one, and one way to get into the right one right here. Now, to get to this one, I just have one option, so I'm going from here to here, and that's my other option, my only option. To get into this one over here to the right, I only have one option right there, right? But to get into this 2, this number right here, I have the option of going here and then here, and I have the option from going from that 1 to this 1 and to that number 2. So I have 2 options of getting here, or 2 ways of getting there, right? My next one is going to be 1. I'm going to add those 2 to find my number right here. So it's 3. I'm going to do the same with 3, and then again 1. My next line is 1. I'm starting with 1. I'm adding those 2, so it's 4. Then I'm going to add those 2, 6, and then I'm going to add those 2. That is 4 and 1 at the end. Okay. As you can see right here, I have something very similar to what we got on the first exercise. I have 4, 1. Sorry, I have 1, 4, 6, 4, 1. Those are my coefficients. Okay. This line right here. This line right here is going to tell you which is the degree that we're using for, which line we're using for, right? So this line belongs to when n is 0. So this line with n is 0, n is 1, 2, n 3, and n 4. So that means the n is going to be the x1 to where we're raising the binomial, right? So in this case, a plus b to the 4th. So I'm going to use this line. Second number in the line is going to tell you this. My coefficient that assume we're going to add numbers and maybe